Hello, my name is Jerry Koo,
And I'm Richard Casillas.
and this is our project for the Ideal 2024 program. So what we have here is a 6-legged hexapod walking robot. It utilizes the Theo Jansen leg mechanism to move around. And to manufacture this, we've used resources from both of our robotics teams, 3473 and 3476. So a bit about our manufacturing process. We've used CNC to cut these side panels, and the legs are 3D printed. We used nuts, bolts, spacers from Home Depot as well as from our each of our robotics teams. And to connect each of the legs, we used sprocket and chain. Some of our biggest issues occurred when we applied the sprocket and chain, because originally we had 5 18-tooth and 5 16-tooth sprockets on our SolidWorks. We actually didn't have any 16-tooth sprockets, so we ended up changing it to all 18-tooth. We had to improvise. Originally we had 10 loops of chain inside of our robot, but now we've reduced it to only 4. And the tensioning of the chain was one of our biggest problems. It led us to have to apply tensioners, and that really helped with the cohesivity of how the legs move now. And also a big challenge for us as well was getting the legs to mimic the same walking patterns of an actual animal. So a little bit about how we designed our walking process for our robot. So we have the front right leg, the middle left leg, and the back right leg touching the ground. And then once it takes a step forward, it'll be the front left, middle right, and back left that have contact with the ground. So the robot always has 3 points of contact with the ground to maintain its balance. And we had to keep the crank angles 180 degrees apart on each side. So it's pretty similar to how you would see, like a dog walking, except with another pair of legs. And you can see how it always has 3 points of contact with the ground. And that's kind of it with the walking process.